Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, we will solve a problem based on rectangular waveguide. So here in the problem given is air-filled rectangular waveguide is given with the specification WR430. So from the given waveguide specification, we are supposed to find the waveguide dimensions, and they have asked us to compute the cutoff frequencies in T10 and T21 modes, and they have filled the waveguide with the dielectric permittivity of 2.22, and they have asked us to recompute the cutoff frequencies for these two modes. So let us first find the dimension of the waveguide. Okay, the m and n values are given, so the mode numbers are given in the question. We are supposed to find the dimensions. So WR430 means the whatever number, three-digit number they have mentioning, whatever number is there, we have to divide it by 100 and write it as inches, in terms of inches. So 4.3 inches, and that if I want to convert to centimeter, I have to multiply it by a factor 2.54. So we get the answer for the A dimension in centimeter. Usually the dimension of B will be half of the A dimension, so we can easily find from A. Cutoff frequency general relation is u dash by 2 into root of m by a the whole square plus m by b the whole square. So here it is filled with air. So in air it's the velocity of light, right? So we have just replaced u dash by c, and we are substituting all these values. N this terms will be n. For n it is 0, right? For T10, m it is 1. So 1 by a the whole square is 1 by a. So that is taken, and this is in terms of centimeters. So making the further simplification, converting into meter, we get the answer for T10 mode. Okay, the cutoff frequency. For TM21, same cutoff frequency formula, but the m and n values are different. So we have to substitute that and find. So we can see clearly here itself the lowest cutoff frequency is for T10 mode, and if it is filled with a dielectric, the u dash we know that it is equal to 1 by root of mu epsilon. So I can rewrite as 1 by root of mu naught mu r into epsilon naught epsilon r. 1 by root of mu naught epsilon naught is c, velocity of light, and that is divided by mu r epsilon r. Mu r they have not mentioned, so we can take it as 1. Epsilon r is 2.2. So what is the inference? Whatever frequency we already achieved, we have to just divide it by the root of the permittivity value that is mentioned. So we can see if it is divided, the cutoff frequency is lower, and similarly for the TM21 mode also. What we can understand, if the rectangular waveguide is filled with air, it has some cutoff frequency, and when it is replaced with some dielectric material, its cutoff frequency reduces. So we will see our next problem. Here a rectangular waveguide dimensions are given, and along with conductivity, permeability and permittivity, and the wave equation for the magnetic field component of Hx along the x direction is given. So from the given in terms of ampere per meter, so we are supposed to find the cutoff frequency, phase constant, propagation constant, as well as the intrinsic impedance. So the cutoff frequency formula we are aware of. There we have to just replace the value given here. Instead of mu, we have to substitute mu naught, and instead of epsilon, we have to substitute 4 epsilon naught. In that case, what happens? Root of 4 will become 2. So c by 2, velocity of light divided by 2 we will get, and if I substitute that value for the velocity, we get c by 4 root of m by a the whole square, where m here is nothing but 1 because no value is given here. For n it is 3. Okay, seeing the kx and ky term, which is m pi x by a and n pi y by b, we can arrive the integers m and n, and we can find the cutoff frequency. Whereas the phase constant, we already know the formula, it is omega. While finding the phase constant beta, we have to substitute instead of root of mu epsilon as mu naught into 4 epsilon naught as given in the question. So in that case, the formula gets changed to omega into root of epsilon r. Okay, and it is divided by velocity of light. and we know the omega value from this expression. It is sine omega t minus beta. Is it omega t is 5 into 10 power 11. Okay, root of epsilon r is what? It is root of 4, that is 2. And velocity of light we know. And then we substitute 1 minus the cutoff frequency that we got early, 28.57 gigahertz. And the operating frequency, it is 50. How we can find? It is from the relation omega equal to 2 pi f. F equal to this omega by 2 by 2 pi. Okay, 50 gigahertz we are getting. So we get the answer in radians per meter. They are asked us to find the propagation constant. Propagation constant is nothing but j beta. So whatever phase constant we get, we have to write it along with beta, and its unit is per meter. And finally, the intrinsic impedance for TM13 node is eta dash, that is intrinsic impedance of phase, or we can write the root of mu by epsilon, right? There that epsilon should be converted into 4 epsilon naught. So root of mu naught by epsilon naught is 377. And root of epsilon r is nothing but 2 here, because it is 4, right? And it is multiplied by the factor 1 minus fc by f the whole square, same factor. So we already know that the intrinsic impedance of transverse magnetic node is less than the intrinsic impedance of free space, that is 377. So that we have to take it. So hope you understood how we solve the problems in rectangular waveguide. Thank you everyone. We will meet in the next session.